Good morning, dear students. My name is Ferhan Mazher, and today is 26th April 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve alternative to practical paper. We call it ATP paper. We also call it paper 4. And today, we have selected October, November 2014 4-1 paper. So this paper belongs from the zone 1 or the variant 1. So let's start this paper. So on your screen, you can see the paper October, November 2014 4-1 paper. This is paper 4 alternative to practical. The time allowed for this paper is 1 hour. The total marks for this paper are 30. So the first question coming up on your screen, a student hangs two pendulums A and B from a meter rule as shown in the figure 1.1. So here are two clamps and they are holding a meter rule, and with that meter rule we have hung two pendulums. This pendulum is a little longer and this pendulum is shorter. This is pendulum A, this is pendulum B. So this is the floor. Describe how the student checks that the meter rule is horizontal. You may draw on the figure 1.1 if you wish. You see, if you want to make sure that this meter rule is horizontal, so there are two methods. One method is we use an instrument that is called spirit level, and the spirit level has a small capsule in it, and it has some liquid in that capsule, and there is an air bubble in the capsule. So if you put that spirit level here on the meter rule, if the bubble will be in the center of the capsule, that will mean that the meter rule is horizontal. Another very easy method of making sure that the meter rule is horizontal is that you find the height of the left end of the meter rule from the bench, the floor, and the right end its height from the floor. If both the ends have the same height from the floor, that will mean that the meter rule is horizontal. So for that purpose, we use a meter rule. We use a scale, a ruler. We place it like vertically here. To make sure that this is vertical to the floor, we put a set square here, and we use a set square here to find the height of this end. And we do the same process here. If both the heights are same, we say that the meter rule is horizontal. So let me show you my written answer. So here you can see I have drawn that diagram. So I have put a scale here, and here I put a set square here. The perpendicular sides of the set square, one of that side is coinciding with the rule, and the other perpendicular side is coinciding with the floor. So that will make sure that the rule is vertical. Then I can use a set square here to make sure that this, what is the height of this meter rule. Same thing you will do with the right side of the meter rule. If both the heights are same, we will say that the meter rule is horizontal. So my answer is, by using set squares and meter rule as shown in the figure 1.1, measure height of the both ends of the rod from the floor. They will be equal if rod is horizontal. I hope you understand. He says marking scheme is showing up on your screen. He says anyone from measure two ends of the ruler from the bench, same height, use of the spirit level, or align with the horizontal objects. For example, the window sill. Allow answers on the diagram. For example, ruler and set squares to measure the height at two places. Check the strings are perpendicular to the meter rule with a set square. So our answer is right. Okay. So we are going to the next question, and the next question is coming up on your screen. He says the pendulum A has a length of 85 centimeter and its length does not change during the experiment. Pendulum B is shorter than the pendulum A by a length X. On the figure 1.1, mark and label the length X. Okay. So here, this is the bottom of the pendulum A with the dotted line I have shown its level. And this is the bottom of the pendulum B with the dotted line I have shown. and these arrows like this, and this means the difference between them is X. So this is that 1 mark question. At least one horizontal line drawn between A and B and X accurately labeled. So our answer is right. Okay, so the next question is describe how the student can measure X accurately. So how you can measure the X accurately if you want to measure the height of this. So one method can be, if you know the height of the string, so subtract that and the radius of this bob, diameter of this bob, from the height of the rod from the floor. Another method can be you can measure what is the height here, directly measure this height. So with the help of a scale. So let me show you my written answer. So my answer is that measure the height of the bottom of A and B from the floor and calculate the difference between there. So describe how the student can measure X accurately. So measure the height of the bottom of A and B from the floor and calculate the difference between their heights. Okay. So measure the height of this and measure the height of this from the floor and subtract them. So that will give you the X value. Okay. Measure from the bench, support the same point on each bob, ensure the pendulum is not moving, explain how the parallax error is avoided. Okay, measure from the bench and support to same point on each bob, ensure the pendulum is not moving, explain how the parallax error is avoided. So you can also write that measure the height of each bob, and to make sure that the parallax error is not there, use the set square. With the help of the set square, because the scale will not be near the bottom of the bob. For that purpose, you can use set square to actually check what is the level of the bottom of the bob on a scale. So, and you have to make sure that the scale is horizontal, is vertical. The bob's bottom is always measured. The height of the bob's bottom is always measured. Okay, so let's move to the next question. He says, the student pulls A and B towards him and release them at exactly the same time. Pendulum A takes longer to complete one swing than the pendulum B. At the start, A and B swings backwards and forwards together in step. Then they become out of step, and after a while, A is swinging afterwards when the B is swinging backwards. So forwards when the B is swinging backwards. They then become back in step, swinging backwards and forwards together. The student counts the number n of the swings of the A until A and B are exactly back in step. The student repeats the experiment and finds n for the different values of the x. The results are recorded in the figure 1.2. Okay, so after 55 swings, they are back in the step. In the step, back in step means they move in the same way. So they will be in the same phase of their vibration. So on the figure 1.3, plot the graph of n on the y-axis against x on centimeters on the x-axis. Start your axis from the origin, draw the smooth curve of the best fit. Okay, so this x value will be on the x-axis and the n value will be on the y-axis. Your x value is going from 3 to 13 and the y value is going from 10 to 55. Okay, so this is the graph. So we will have to label here. I will represent n, and here I will represent x, and let me show you. Then I will plot these points. So here you can see that I have labeled this thing as n on the y-axis, 10, 20, 30, 40, 50, and 60. And here I have labeled this axis as for x in centimeters, and this is 2, 4, 6, 8, 10, 12, 14. Then I will plot these points. At 3 we have 55, so this is the point. At 3 we will have 55. At 5 we will have 32. At 5 we will have this point 32. And then at 7 you will have 22. At 7 we will have 22. And at 9 we will have 17. At 9 we will have 17. And then at 11 we will have 13. At 11 we will have 13. And then he says the last one, 13, 10. At 13 we will have 10 value. So then I will join them. Their question was draw the smooth of curve of the best fit. So what we will do, we will join them with the smooth curve. So we have tried to join them with the smooth curve. Then their question is, let's check. After drawing, before he says, yeah, before taking any reading, the students attach the pendulum A and B close together on the meter rule. Give one reason why it is helpful to have the strings close together. When the strings are, both the pendulums are close together, then it is very easy for us to observe them both immediately or together. Okay, so that's the one benefit. Then he says, so just one problem this may cause, the one problem this may cause is if the pendulums are close to each other, they might get tangled with each other. Okay, so let's have a look. So give one reason why it is helpful to have the strings close together. When the strings are close, it is possible to observe both A and B simultaneously. Bobs may collide with each other. That's the problem, or they may tangle. Their strings might tangle with each other. So let's have a look at the marking scheme. Or the marking, at least one horizontal line before A and B accurately labeled. Okay, so this one is axis labeled quantity and unit, scales linear points plotted accurately, best fit curve drawn. It's a 4-mark question. Observe both together, observe simultaneously. At any one from strings tangle or bobs collide. Okay, so let's move to the next question. The next question is, he says the length LA of the pendulum is 85 centimeter. The length LB of the pendulum is 75 centimeter. Use your graph in the figure 1.3 to obtain a value for the N. Okay, so first of all, I will find the value of the X. Value of the X is LA minus LB, and that will be 10. So from the graph, I will go for the X10 value, and I will check what is the value of the N. I will write it here. For example, let me show you. So here you can see the X value is 10. So then I will go to the graph, and at 10, I will check what is the value. So at 10, the value will be something like, this is like, I think 15 or 16, I think. So let me check. Sorry. So the value will be 15. This is coming from the graph. Okay, so first of all, I have found the value of the X. And then I have checked the value of the X on the X-axis and then gone to the graph. And there I have checked what is the value of the Y there. So he says theory shows that the N is under root LB by under root LA minus under root LB. Calculate the value for the N when the LA is 85 and the LB is 75 centimeters. You just have to put the values of the lengths of the A and the B here and just do the calculation. So in your calculator, find what is under root 75 divided by bracket start under root 85 minus under root 75 bracket close equals to, and that will be 15.48, and that's approximately 15 vibrations. So both these values from the theory and from the graph, they are same. Comment on whether your two values for N are in agreement. Yes, they are in agreement, and values in the E first part and the E second part are same. So that's our answer. Here we go. The marking scheme is showing up for the E part, and he says if both values are the same, yes, they are the same. So hopefully you understand, and it's clear to you how this is done. So let's move to the next question. Okay, here we have a group of students measures the heights of the seats of 5 similar laboratory stools. The stools are shown in the figure 2.1. State the name of the suitable instrument for measuring the height. The height of the stool can be measured with the help of a scale. And explain what is meant by a parallax error. Parallax error is if your line of sight is not perpendicular to the scale, then due to the wrong positioning of the observer, he will get a wrong idea of the measurement. That is called the parallax error. So let me show you the definition. So 1 mark question. He says that in meter rule, and yeah, if line of sight of the observer is not perpendicular to the scale, error in the measurement due to the wrong positioning of the observer is called parallax error. I hope you understand this. So let's check the marking scheme. The marking scheme says meter rule, error in taking measurement due to the position of the observer. Okay, so the next question. Describe how the student can avoid parallax error when measuring the height of a stool. Whenever you are measuring the height of the stool, the observer's eye or the line of sight must be perpendicular to the scale on that position, on that location, from where you are going to read the actual measurement. Your line of sight must be perpendicular to that place. Observer's eye and the line of sight should be at the same level as the height of the stool. That can be in these words also. So let's have a look at the marking scheme. He says the view from the level with the top of the stool. Okay. And then his C part is, he says, the student obtained the following results. The heights are measured in centimeters: 62.2, 37.6, 61.9, 62.5, and 62.1. One of the results is very different from the others. This one is different. Okay. So suggest once how the student used the measuring instrument incorrectly to obtain this result. You see here the scales are put in the right upright position. Okay. But here he has by mistake he has what you say, upside down. He has reversed the positioning of the meter rule by mistake. So now the 100 centimeter mark is upstairs, and you see the 0 mark is on the ground. So he has rotated his rule by mistake. So let me show you my answer, and then you see. He has placed the meter rule upside down. Okay. So what's the marking scheme says? Meter rule upside down. Okay. Then what's the question? He says calculate the average value of the height of a stool. Give your answer to 3 significant figures. So 1, 2, 3, 4. Add these 4 values and divide it with the 4. You will get the average value of the height. So very simple. So we will add those 4 values: 62.1 plus 61.9 plus 62.5 plus 62.1 equals to, divided by 4 equals to, and that will be 62.175, which is 62.2. 62.2 centimeter is the average height. Okay, so let's have a look at the marking scheme. 62.2 centimeter is the answer, sir. Okay, so now the question number 3 is coming up on your screen. In the question number 3, he says, a student calibrates the thermometer. Figure 3.1 shows the thermometer with no scale marked on the stem. Describe how the student finds the correct positions for the 0 degree centigrade and 100 degree centigrade points on the thermometer. So you see on the thermometer, if you want to mark the 0 degree centigrade mark, you will place the thermometer in the melting ice. And when the level of the mercury will become steady, and when the level of the mercury will become steady, with the help of a marker, mark a point on the thermometer, the level of the mercury, mark its positioning, and we will call it 0 degree centigrade. It is the lower fixed point. Then place the thermometer in the steam of the boiling water, and obviously the level of the mercury will rise upward. When the level of the mercury will become steady and the thermometer is in the steam, when the level of the mercury becomes steady, mark the position of the level of the mercury with the help of a marker on the thermometer, and we will call it the steam point or the upper fixed point. or 0 degree centigrade? It's a 2 marks question. So let me show you my written answer. Okay. Place the thermometer in melting ice when level of the mercury becomes steady. Mark its level. Place the thermometer in the steam of the boiling water when the level of the mercury becomes steady. Mark its position as the 100 degree centigrade. So I hope you understand. So let's have a look at the marking scheme. Place the bulb in the pure melting ice. Place the bulb above the boiling water in the steam. Okay, so we are good. Okay, so next question. He says the figure 3.2 shows the thermometer with the 0 degree centigrade and 100 degree centigrade marked by the student. The thermometer in the figure 3.2 is at the room temperature. Okay, so this level is showing the room temperature. By taking measurements from the figure 3.2, calculate the value for the room temperature. Show your working. Okay, so very good question. Let me show you. Okay, so let's say that's up to you. I started this point as a reference. I use this point as a reference. So this length is showing for the 0 degree centigrade. This length is showing for the 100 degree centigrade. And this is the length for the room temperature. So I will measure them with the help of a scale. For example, for the room temperature, the length is 3.5 centimeter. For the 0 degree centigrade, the length is 0.8 centimeter. And for the means the 100 degree centigrade, the length of the mercury column is 12.24. So this is the starting point, the reference point from where I'm measuring the length for the mercury level. So the formula is L theta minus L naught by L 100 minus L naught is equal to theta by 100. L theta is 3.5 minus L naught means minus 0.8 divided by L 100 is 12.4 minus 0.8 equals to theta by 100. So 3.5 minus 0.8 and that will be 2.7 divided by 12.4 minus 0.8, that's 11.6 equals to theta by 100. Cross multiply and theta will be equals to 2.7 multiply 100 divided by 11.6 and that will give you 23.2758. So which is 23.3 degrees centigrade. So the room temperature is 23 point something. So it says the answer is in the range between 22.5 to 24.6. So our answer is in this range. Okay. So the next question. State one assumption made in calculating the room temperature. So the assumption is that the liquid is expanding uniformly with respect to the temperature, with the change in the temperature. Okay, so that's the answer. Question number 3 is done. So let's move to the next question. The next question is coming up on your screen is question number 4. A student is given a 1 meter length of the thin wire of approximately diameter 1 millimeter. She is asked to measure accurately the diameter of the wire. The other apparatus available is marker pen, pencils, meter rule, scissors, 30 centimeter ruler, blue tack, thin string, sellotape, thick string, lined paper, wooden rods of various diameters, and the plain paper. So describe in detail how the student can obtain an accurate value for the diameter of the wire using some of this apparatus. In this account, you should state the equipment used, explain how the equipment is used, state and any reading taken, explain how the value for the diameter is obtained, describe how to make the measurement accurately. So it's a 5-mark question. So let me show you, and it's a 5-mark question. So what we will do, we will take a scale, and so I will take a scale like I have shown here, and I will wind that wire around that scale in this way. So I will make sure that all the turns are touching each other. So there is no gap between the. And then I will check that from here to here, how much is the length on the scale. And I will count how many turns of the wire are there. So I will divide this length AB with the number of turns, and that will give me the diameter. Wind the wire around the scale such that the loops of the wire have no gap between each other. Count the AB length on the scale for the 10 turns of the wire. Divide, for example, for the 10 turns, we have done this. Divide the AB length with the number of turns, it will give you diameter of the wire. Repeat with the same turns and and take average value of the diameter. So for example, you can take more turns, like 15 turns, and you can find the diameter and then take the average. So let me show you the marking scheme. He says 2 methods can give gain up to 5 marks. Cut the wire method and line up horizontally, maximum 3 if less than 10 cuts. Wrap the wire around a rod or a ruler, maximum 3 if would less than 10 times. We have at least taken 10 times. Okay. So any other method, maximum 3 marks if viable. Equipment used, stated in account how equipment is used, reading taken, stated how diameter is obtained, and details of the accuracy. So you repeat that experiment, that's the detail of accuracy to get the average value of the diameter. Okay, so the next part is he says, state the name of a measuring instrument that the student can use to find the diameter of the wire more accurately. We can use, we can use a micrometer. So a micrometer can be used directly to measure the diameter of the wire accurately. So my dear students, we are done with this paper. So today, my dear students, we have solved October-November 2014 a 4-1 paper. This was alternative to practical ATP paper. We call it paper 4. The time allowed was 1 hour. I have tried my best to explain you the concepts. I hope that this video will help you to understand the basic concepts of this of the experiments involved. If you find this video interesting, informative, and helpful to you, do share the link of this video with your friends and with your class fellows and with your junior students. Also share the link of this video on your Facebook accounts, Instagram accounts, Twitter accounts, because that will help me to promote my channel. It's a great blessing for me to be able to teach you online. Thank you very much. Have a good day. God bless you all.